Hello everyone. In this particular video, we are going to solve the problem Irodov, problem number 1.8, and that is related to kinematics. So let us first read out the problem and then we'll solve the problem step by step. So there are two boats, A and B, move away from the buoy anchored at the middle of the river along the mutually perpendicular straight lines. So let us see in this picture, this is the buoy which are anchored at the middle of the river, and by using some chain or some sort of object, and this is the floating body. So and it is used for some navigation purpose. If you are more interested, you can go through Wikipedia and then you can read. Okay, so let us come to the problem. So basically this is the buoy which is in the middle of the river. So this is the buoy which is in the middle of the river, and then we are having the boat A and boat B. Okay, the boat A moving along the river and the boat B across the river. So this is boat A which is moving along the river, and this is the velocity of the flow, which is, let us say, V. Let us denote it as V, and then this is the direction of the motion of the boat B, which is perpendicular to the direction of motion of the A. Okay, now it is saying that having moved off an equal distance from the boat, the boats return. So when the boat A and B both has reached to some equal distance, let us say D and D, then the boat A has started move in the opposite direction of the flow, and then boat B has also started moving towards the buoy. Okay, then it is asking the ratio of the times of the motion of the beat TA and TB. Then it is asking to find the ratio of time taken, total time taken by boat A and boat B, and it is given that the velocity of A with respect to flow is equal to 1.2 times V, that is the flow velocity, and then velocity of B with respect to flow, that is also given as 1.2 times of V. So these data are given. Now let us analyze the motion of boat A first, then we'll move on to boat B. So let us consider boat A. Okay, so this is the river, and in this river the boat A has started from the middle in the direction of the flow, and velocity of A with respect to flow, it is given as 1.2 V, and the flow velocity, it is given as Vf is equal to V. Now as it is moving in the direction of the flow, both has the same direction, then to find the net velocity of A, we can simply add the magnitude of the relative velocity and the velocity of the flow. So we can directly add, because both are in the same direction, we can directly add 1.2 V plus V is equal to 2.2 V. So this is the net velocity of the A when it is moving towards the flow direction. Now as it has reached to point D, let us say, and the B boat has also reached to point D and both are same, and that then it will try to move in the opposite direction of the flow. Okay, so while moving in the opposite direction, let us consider the another case. While moving in the opposite direction, then the boat is actually moving in this particular direction, and the flow is having in this direction with velocity V, and it is moving in this direction. Velocity of A with respect to flow is equal to how much? 1.2 V. And from the relative velocity, we know that velocity of A is equal to velocity of A with respect to flow plus velocity of A. Now we know that what is the velocity of A with respect to flow, that is 1.2 V, and both are in the opposite direction. Both are in the opposite direction. That's why we have to put minus here. So we can get velocity of A is equal to 0.2 V in this particular direction. Now in the both cases it is moving the distance of how much, this is the location at which boy is there. So this particular distance is d and this particular distance is also d. So we can now find the total time taken total time taken by A, that is equals to, in this particular case, what is the distance it is traveling d and what is the velocity at which it is moving, that is 2.2 v. 2.2 v plus in this direction, when the velocity is in the opposite direction of the flow, in that case the distance traveled is t and what is the velocity, 0.2 v. If we calculate this one divided by 2.2 plus, so we'll get around 5.45 d upon v. So this is the time taken by the boat A for the entire motion. Now talking about boat B. So this is the river, and here in the middle the boy is there, and then from this particular point the boat has started moving in this particular direction with respect to ground. So with respect to ground, as we are able to see that the boat is actually moving in this particular direction and the flow has the velocity of vf is equal to v, then we know from the relative velocity concept that it has to move in this particular direction with respect to flow. Because if with respect to flow, if it is moving in this particular direction and this is the flow direction, then we can get the resultant of motion of the boat in this particular direction. Okay, so uh, with respect to ground, the boat is moving in this particular direction and the flow has the motion in this particular direction. So with respect to the flow, the boat has to move in this particular direction so that the resultant motion will be in this direction. Now this is the velocity of boat B with respect to flow, that is given as this is given as 1.2 v, and what is the flow velocity, that is v. And let us consider this is angle theta and this particular component is 1.2 v cos theta and this particular component will be 1.2 v sin theta. Okay, now we know that the flow the boat B has actually the motion in this particular direction, so it will not have the component of velocity in the perpendicular direction, so we can equate both these velocities. Okay, so if we equate both these velocities, then we can get v is equal to 1.2 v cos theta. So cos theta we can get 1 divided by 1.2, which is equal to 10 upon 12. Okay, and from here sin theta we can write 1 minus cos square theta under root, that means that is equals to 1 minus 10 upon 12 whole square under root. Okay, so this is the sin theta will get. And what is the velocity of the boat? Net velocity of the boat we can write 1.2 v sin theta, so this will equal to 1.2 v 1 minus 10 upon 12 whole square under root. If you calculate this one, then we can get velocity of B is equal to 0.663 v. Okay, now as it has reached to this particular point at a distance of d, which is equal to what the A has reached to this particular point with the same distance, then the boat B has to move in the towards the direction of the boy. So let us consider that particular case. So in this particular case, this is the boy and the boat is here. Now in this case, the boat has to move in this particular direction and with respect to the ground, and the flow velocity is v, it is given. So with respect to the flow, the boat has to move in this particular direction. So this is the velocity of boat with respect to flow, and this is the velocity of boat. Okay, and again this is given as 1.2 v. So this particular angle, let us say theta. So what is this particular component? This is 1.2 v cos theta. Again we know that it is moving in this particular direction, so perpendicular direction velocity can be equated. So we can write v is equal to 1.2 v cos theta. Again we got cos theta as 10 upon 12. So velocity of vb we can get, this particular component was 1.2 v sine theta. So we can write 1.2 v sine theta, which is equal to 0.663 v, because this is the same case as the previous one. Now if we talk about the total time taken by the boat B, so in the first case it is moving by distance d, and what is the velocity it is by which it is moving? 0.663 v, plus in the second case when it is moving towards the buoy, in that case the distance traveled is d divided by what is the velocity? 0.663 v. So we can get 2d divided by 0.663 v. Okay, so this is the time taken by boat B to complete the entire journey. Now it is being asked that to find TA upon TB. We know what is the value of TA. So TA is 5.45 d upon v. So we can write 5.45 d upon v divided by 2d upon 0.663 v. So if we solve this particular thing, we can get around 1.8. So TA upon TB is equal to 1.8. I hope the entire procedure is clear. Let us summarize it once again. So near the buoy, that was at the middle of the river, we were having the two boats A and B, and A was moving in the direction of the flow and B was moving in the perpendicular direction of the flow. When both A and B has reached a certain distance, and when both are equal, then both were coming in the opposite direction of the flow, while when it was moving that particular direction, then it is asking to find what is the total time taken by boat A and boat B, what is the ratio, and velocity of A with respect to flow is given as 1.2 v, and it is same as velocity of boat B with respect to flow. Now coming to boat A, we are having the river, and in the river boat A is actually moving along the direction of the flow, and when it is moving in the direction of the flow, we know that, and it is given as the velocity of A with respect to flow, it is given. So we can directly add in order to find the net velocity, and when it is moving in the opposite direction, we can subtract the relative velocity and the velocity of the flow. Then we have found out the time by the formula distance upon velocity, because here there is no acceleration. Okay, then for the boat B, we knew that the velocity of the boat is actually in this particular direction, and flow velocity is in this direction. So we know that with respect to flow, the boat has to move in this particular direction, and we have found out the component along the flow, along the motion of the boat B and the perpendicular to it, and we knew that the velocity is in this particular direction, so perpendicular to it has to be cancelled each other. So we have equated v and 1.2 v cos theta, and that was the same case when it was moving towards the buoy. Then we have found out the velocity of the boat in both the cases, and then we found out the time taken to cover the entire journey, and then we have found out the ratio. I hope the entire procedure is clear. Thank you.